these two demos are recorded versions of it that we showed at Intel Innovation. So this is the real data, but it's recorded. So I was able to put some overlays, but I do have to wait. Go ahead and hit play on, which one are you on?
First one.
Okay, good. So what this one does, and actually just hit pause so I can explain this real quick. So what we're going to look at is the number of objects that are being processed, maintaining the KPI. So if you look up at the upper left-hand corner, that's the KPI. And remember, I mentioned it has to be 5 frames per second. So we want to stay as close to 5, or above 5, but as close to 5 as we can, right? Because anything more than that's kind of a waste. So we have the number of objects, and then we have our target power. So that's the intelligent side of it, saying the number of objects is lower, our KPI is high. I mean, we're well above the KPI. We're recommending move to 1, 2, or 3. Let's try to keep things simple, right? 1, full power Xeon, two servers running, and we've got everything up at full power. 2, go to low power state. So go to power, power save, allow things to go down. It could be what Patrick's doing, dropping the cores and so forth. Or 3, move the workload to the IPU and run it on the lower power cores that are actually on the IPU DPU, right? So actually move it down and then, so go ahead and start back up now. And what you'll see, so then you see your total power at the top, and then in the middle here is the Xeon use, IPU use, and then where the workload is running is down on the bottom down here. Now, unfortunately, this is where we have to wait for, thing about telemetry data, data is what Patrick was saying, there's delays, and you actually have to wait for it to come up. So you'll notice we dropped from 30 frames down to 15, or 32 down to 15. KPI, now we're up at 12. So technically, we're wasting processing, right? We're doing more than's useful. And so you'll see at this point, telemetry will say, hey, drop this to a 2. And eventually here, it will come up. Other things are actually moving down below. There you go. So it says, hey, recommended was a 1. Now we're over. It will go to a 2. This is where you really want to fast forward. That's one other reason we don't do these live. We usually speed up things and chop them because they're kind of like watching paint dry sometimes. Okay, so now we're at a 2. You'll see the power. We're at 233 watts. The power gauge already dropped because things in the background already happened, and it moved to the lower power state. Even though the number 2 didn't pop up, it waits. The way this thing is, it waits till it gets down, and then it says, "Yes, I'm there." So it's kind of like a 1.5 there for a while. So we're back down close to the KPI at 5, right? So the next one, and we'll just let it pop up, and then we'll skip over to the other demo. So
you want me to go to the other one?
Not quite yet. We'll show. So the workload is going to get migrated. So we only got one object. So we can really reduce the power, move that over to run on the IPU. Drop, because we only need processing for one object, right? So this is one way of being able to do this at the edge, or in closer to the edge with these type of workloads. So you'll see it drop down. So let's go ahead and jump over to the other one. So on this one, we're going to go based off an energy forecast. So at 1400 watts, if our forecast is at 1400 watts, and that's when the bar is all the way up the top up there, we're going to run at full speed. We're going to have both Xeon systems up and running. Right now, it's down on the lower section. So the energy forecast is well below. It's like at 250. So we're running one pod container on on the IPU. Now, in this case, we have one of the Xeon systems completely off, and then we have the other Xeon in low power state, still running with the workload running on the IPU. So that's that green line that you see that still has power, the yellow one's down at the bottom. So as the workload, or as the energy forecast, and the energy forecast could be your ratio of renewable energy to non-renewable. So whatever that forecast is, how much you have available because of the amount of solar you have.
Yeah, I was going to ask what the forecast meant in this context. It could be like
it could be anything.
I'm on a boat and my solar system says, "Hey, look,
yeah." So it all depends on, it's kind of like what Patrick's saying. Whatever that the busiest indicator is what we used. It could be anything, right? Or it could be a combination of a bunch of things and say this is what we have, right, for that time, that space. Energy forecast. We know we're going to need additional power because it's rush hour. So that is kind of just a variable of some sort for this demo. So what we did is we knew the energy forecast was coming up. Once again, the data is a little delayed on the screen. So we're going to spin up 230 pods instead of just running that one, because we know we're going to need them. So you'll see the energy forecast going up, and then you'll see the the going from 267 watts up to 1,200, 1,400 watts, whatever the maximum is. So that being able to look at whatever that forecast is, having the intelligence behind that, being able to predict what the workload requirements are, getting all this information to kind of play together is actually a lot easier in a data center because you have a lot more control over the different variables. But once you start moving out to the edge, this becomes very challenging. And how do you create a network or a series of endpoints that you can move things around in order to do this type of work? And that's some of the pathfinding work that we're doing on the edge side. So any questions on those two concepts? I mean, some of this is like, yeah, that makes sense. Have you ever thought of it? Maybe not. That was the way I was like, yeah, this, now how do you do it? So we put the slides in for the demo. So people who don't get to see the demos, some of the different things with the dynamic voltage and frequency scaling technologies and stuff, go ahead. So these are the summaries, basically being able to run at high energy. So you have a lot of energy available. And because you have 32 objects, you need to use the processing, and then being able to scale it back when you don't need it. And I think that's one of the critical hardware pieces that we have to be able to figure out is what are those knobs that we need to turn? Because as you were saying, yeah, you can bring your systems down, but the response time of bringing them all back up, and that's why I kind of go ahead and go to the next. But that's why when Patrick, he said, hey, take a look at this thing. I'm like, that local agent, being able to adjust it and having some more intelligence behind that, and also having the ability of manual override during these times, don't touch it. I know it doesn't look like you're busy, but you're about to be. Game's just getting out. Get ready. Move everything how you need to be, and around a stadium, that type of stuff. That's what, hey, new cat video just came out. It's going viral. Everybody's, hitting the web. Get ready, those type of things. I mean, we joke, but no, that takes networks down.
Turn them.
Yeah.
Taylor Swift made a tweet. Oh my God.
Yeah. So, but also being able to look at, making these, adding more inputs into it, but being able to respond to them around the CO2 awareness, right? And those are the things that, we probably cared about but didn't implement. And now we're starting to implement those type of things into these different demands. Go ahead and go to so this next slide will just be the summary. Wow.
Hey, there's a huge delay. I don't know what's going on.
Is that
sometimes. Just roll with it.
Yeah. So anyway, the summary, being able to move, and this is, being able to move from an Intel architecture down to an ARM architecture and vice versa, being able to move those workloads, being hardware independent, and platform independent. Those are the type of things that we really need to start looking at. And go ahead and go to the summary. Wow. So one of the things that, the big area on this, on the edge is there is really a lack of standard, right? Everybody, it's kind of the Wild West out there. People are coming up saying, hey, we're going to go do these things. We really need to start looking at how to build the standards to make things, to start implementing things right to start with. Because once we start getting stuff out there, it's a lot harder to change, and yeah, I just really look at, how can we implement these things better today, and taking that extra time to make sure instead of just getting something out there, right? Because that's been a huge challenge. And then the unified architecture, really think about how can you control how you're using energy, how can you work with those other devices that are out on the network near you, within the building, within, sites and so forth. How can we make those things better? There will be there's some additional backup slides and stuff in here. But, reach out to us if, and if you're interested in being part of, on any of these working, projects that we presented here, and there's a ton more. We have, it is an actual Intel mandate. We have the, now I'm drawing a complete blank on the whole initiative at a corporate level. I can't remember the name of it.
Sustainability.
Well, it's sustainability, but there's a marketing name for it. But anyway, it is really important, and all of us need to kind of think about how can we help in each of our areas